Hello, fellow foodies. Welcome back to Foodie Pharmacology, the science podcast for the food curious. On this episode, we're going to dive into a really cool food topic. It has to do with wasps, bumblebees, yeast, and sour beers. In other words, we're going to talk about bumblebee beer. Our special guest today is Dr. John Sheppard. John is a professor in the Department of Food, Bioprocessing and Nutrition Sciences at North Carolina State University. He received his PhD in chemical engineering from McGill University in Montreal, Canada, and an MBA from ESCP in Paris, France. He currently teaches biopharmaceutical production in the Biomanufacturing Training and Education Center at North Carolina State, and his research is focused on the development and control of fermentation processes, especially when they're applied to brewing. He's also been the director of the North Carolina State Research Brewery since 2006 and operates a company that supplies wild yeast to the brewing industry. Welcome to the show, John. It's great to see you.
Yeah, so thanks for inviting me. I'm excited.
Yeah, I'm excited to learn more about the brewing process. Maybe we can start with just a basic overview is how is beer traditionally fermented or brewed?
Yeah, so brewing is divided into two main sub-processes. The first is actually done in what's called the brew house, and that's actually the brewing part of making beer is in the brew house, and that's where we take grain, usually malted barley or wheat, although there's a number of different substrates that can be used to make beer, but the European tradition, which we adopted in North America, is mostly malted barley. We take that malted barley and we essentially cook it in hot water, and in the cooking of it in hot water, the natural enzymes in the barley get activated, and it hydrolyzes the starch and the proteins into fermentable material. Okay, and so after about 1 to 2 hours, depending upon the conditions used, this is called mashing actually, which is the first part of the brew house. After 1 or 2 hours, we transfer what's called the wort, which is the fermentable sugar mixture, into the kettle. And in the kettle, we boil it in the presence of hops. So that's where we add the hops. And during the boiling, the what are called alpha acids get extracted from the hops. And this is what causes the bittering effect in the beer. Okay, so the boil goes on for about an hour, and then we stop boiling. We usually try and get rid of the solid material that is left in the kettle by whirlpooling, and then we cool it as we pass it through to the fermenter. We cool the wort, and once it's in the fermenter, we set it at the fermentation temperature, add the yeast, and then the magic begins. The yeast produces the beer over the next 1 to 3 weeks, depending upon the style of beer and the yeast that we're using. And at the end of that, we usually try and remove as much of the yeast as we can, add a bit more CO2 to give it a nice head, and then we package it. So that's brewing in a nutshell.
That's great. That's great. Well, what's amazing to me is that all beer starts with this basic ingredients of, like you said, the malted barley or malted wheat. And malting, by the way, is that just where you have germination of the seeds? So they're starting to sprout?
Yeah, so there's a few steps in malting. First, you have to steep the grain. So you put it in a big vessel and add water, and so the grain absorbs all this water and essentially also activates the germination process. And then you drain the water off, you lay the grain seeds on a floor that is usually perforated so that you can get some air circulation around the seeds, and they germinate. They produce little roots, and once you see those little roots, you need to stop the germination because you don't want too much of the starch to be converted into sugar for the plant. You want to keep that for your beer. So you stop it by then drying the seeds. So you put them in a kiln to dry them, and then that's the malt that is very stable then in the dry form. And those enzymes then that you activated during germination come to life again when you mash during the brewing process. So you add the water back again, and this reactivates those enzymes.
Fascinating. So we're starting with these basic ingredients, but there are so many different types of beer. So how do we get from this basic starting ingredient to so much variation in beer types?
Yeah, so nowadays with the craft industry, it becomes even more complicated. It used to be like if you're a traditionalist, there weren't all that many different beer types. I mean, you can divide beer into the two basic kinds, which is ales and lagers. And then within those divisions, there's probably another 20 kinds of ales and 20 kinds of lagers that are, well, not 20 kinds of, at least 20 ales and maybe 10 kinds of lagers from the traditionalist point of view. But nowadays, in the craft industry, people are putting all sorts of different flavoring compounds into beer that normally, if you're a traditionalist, you wouldn't be doing that. So there's all sorts of new styles coming up all the time. There are hundreds of styles now. And basically the style is going to be determined by the specific raw materials you're using and the specific kind of yeast. To some extent, the kind of yeast also will determine the style. But it's basically the two most important raw materials for flavoring are going to be your source of sugars and your source of bittering. And hops, there's lots of different kinds of varieties of hops that provide different characteristics to the beer, both from a bittering and aroma point of view. So hops and the kind of malt that you're using, and whether you're adding some other kind of flavoring ingredient will determine the style. So the yeast usually is chosen based on those other ingredients. So, if you're using a very strong wort, like with a very high concentration of sugar, like you would with, some of the ales that are considered to be high gravity, like 7% alcohol, then you have to use a special yeast for that. So the style of beer really dictates the yeast in a way that you're going to normally use.
That's great. And so what does the yeast have to do to transform these materials into beer? Like, what is the main work of the yeast?
Okay, so the main thing the yeast does is take the sugars, the fermentable sugars, which if you're using an all-grain recipe like malted barley as your major source, the major sugar there is going to be maltose. Okay, so it's a disaccharide, and the yeast are going to convert that maltose into ethanol and carbon dioxide. Okay, so that makes the basis for your fermentation metabolism, is a conversion of that sugar into ethanol and carbon dioxide. Now, along the way, it also adds flavors to the beer while it's doing that. And a lot of those flavors are a result of amino acid metabolism. So there are some free amino acids that are released during the mashing, and these amino acids are necessary for the yeast to be able to grow and ferment that sugar. But byproducts of that amino acid metabolism are things like esters. And these esters provide the kind of the yeast flavoring to the beer. And depending upon the type of ester and how much of it, is it above the taste threshold, is it below the taste threshold, will determine how that particular yeast is not only making ethanol and CO2, but is also affecting the flavor and aroma of the beer.
Nice. So when we think about commercial yeast, are there a set number of strains that are used? Or I know that you've also done a lot of work in exploring new sources of wild yeast. Can you tell us a bit about what is the advantage of working with different types of yeast?
Okay, so if you look at commercially available yeast, they're divided into 99.9% of them into two different species. Saccharomyces cerevisiae, which is also called baker's yeast, and Saccharomyces pastorianus, which is the lager yeast. So Saccharomyces cerevisiae is used to make ale, and Saccharomyces pastorianus is used to make lager. Okay, so those two species make 99.9% of all the beer. Now, within those two species are dozens of different strains, okay, and those different strains are what make the yeast, for example, more ethanol tolerant, or more sugar tolerant, or changes their temperature effect, and how much ester they produce, or what kind of esters. So the strain of the yeast, the devil is in the detail there, really, about how they do affect the beer. Now, there are rather subtle differences between so-called brewing strains, because there are some basic criteria that for the yeast to be useful in the brewery, it must be able to fulfill. And a lot of strains of Saccharomyces cerevisiae, for example, won't work as a brewing strain because they just don't fulfill these basic criteria. And these basic criteria are essentially, they have to be very tolerant to high concentrations of sugar. Okay, so if you look at the sugar coming out of the brew house, the sugar content of the wort, it's quite high. You're talking about 150 grams per liter and up, even as high as, over 200 grams per liter sometimes. So this is a really sweet solution, and a lot of yeast can't tolerate that. It's too much sugar, and they're not going to get going. Their metabolism isn't going to get going. So they have to be tolerant to that. And the second thing they have to be able to do is convert that sugar efficiently into ethanol. So you need to get a high yield of ethanol from whatever sugar is being used by the yeast. And again, this is a rather unusual feature of brewing strains. By far, most yeast strains, even if they produce a little bit of ethanol, they get inhibited themselves by the ethanol. Mm-hmm. So they stop making it at quite low concentrations. So to get a yeast to be able to go up above 5% ethanol is relatively rare in nature. Mm-hmm. So both winemaking strains and brewing strains of Saccharomyces cerevisiae have been selected over the centuries to be ethanol tolerant. Okay, so those two things, being tolerant to high sugar and tolerant to relatively high ethanol, and be able to produce ethanol at high yields without producing too many off flavors. So this is the thing that is the unfortunate thing about many of the wild yeast that you may be able to isolate, just from your backyard or whatever. They may be able to ferment the sugar, and they may give you a reasonable ethanol yield, but often they make some compounds that really make the beer unpalatable. So to have a nice flavor with a good yield of ethanol is kind of a rarity. And for that reason, it's these strains of brewing yeast that have really been selected for over the centuries, that are used predominantly by commercial brewers. To use to get a wild yeast that actually gives you a palatable product with a good yield of ethanol is quite difficult.
Yeah. Well, and I know this is an area that you've dedicated a lot of research to, and besides Saccharomyces, you've investigated other genera. Can you tell us about Lachanacea and what that yeast is like, and where did you find it? How do you search for new yeast?
Yeah, so this was a team effort when we first did this. Dr. Ann Madden was the microbiologist that was involved with this, and so it was really a challenge given to us by a fellow here in North Carolina that was organizing the North Carolina Science Fair, and he said, can you come up with a special beer for the science fair? And I said, well, okay, maybe, but what's your idea about a special beer? And he said, well, maybe you could use a wild yeast. So anyway, he connected me with Dr. Madden, and she was actually doing a project with some graduate students, and they were trying to isolate yeast from the gut of bees and wasps. So she was in this class she was teaching, they were able to do this, and they isolated them. And then she had a selection procedure she used where she would only pass on to me yeast that were able to ferment maltose. So I told her that there's no sense giving me a wild yeast if it can't ferment maltose. Mm-hmm. So that was her main thing, was she was using that as the primary sugar source when she was isolating this yeast. And so she gave me a couple of different strains of yeast that she didn't actually know what the species was or the genus. We didn't. So we just assumed actually that it was Saccharomyces cerevisiae, because maltose is not very common in nature. You can imagine that grain, because it comes from malted grain, and where is that in nature? Well, I don't know. Anyway, this particular yeast was able to ferment maltose, so I tried making some beer with it, and I bottled the beer, and then we went to this lab, and we were all sitting around the table. We had about half a dozen people, and I said, look, this is the beer, but I don't think you're going to like it. So I opened the bottles and I poured out the beer, and gosh, it was really different. And what made it really different, which I didn't know at the time, was that this particular yeast that she had isolated also produces lactic acid. So the beer was really sour. And I was like, whoa, that's not Saccharomyces cerevisiae that's doing that. Because there's no known strain of Saccharomyces cerevisiae that produces lactic acid. So then we got thinking, I initially didn't like the beer at all. I thought it was, of course, it wasn't what I was expecting either. So to make a long story short, we did take the beer to the science fair, and a lot of people really liked it. Like, this was when sours were starting to become more popular among craft beer drinkers. So a lot of people really liked it, and it was very unusual, that's for sure. So then we decided maybe we should investigate this a bit further. So we actually got an identification done of the yeast, what it actually was. And as it turns out, it was Lachanacea thermal tolerans, which is, it used to be called Cerevisiae thermal tolerans, but it was renamed, I don't know, I guess about 10 years ago now. And it was known in wineries as a contaminant in some winemaking.
You don't want sour wine. Yeah.
Well, interestingly, you say that, but some styles of wine actually you want to have there's a fair bit of acidity in wine, much more so than in standard beer, which the pH of standard beer is around 4.2, whereas this yeast was taking our beer down below 3.5.
Wow.
So it was pretty sour. Yeah. Anyway, so we thought this was kind of a unique thing, and the thing about these two particular strains of Lachanacea thermal tolerans that we had was that it was able to produce good yields of ethanol, which is really what you need if you're going to use it as a primary culture to make your beer. And the flavor components it made were really very pleasant. I mean, it was a very fruity, kind of flowery character to the beer. So after I was able to design specific recipes for that, now that I knew what the yeast was doing, I could make a recipe that complemented the characteristics of the yeast. We were able to come up with some very palatable beers with this strain of yeast. So it was kind of just a chance how it occurred, but you know, you never know. So
I know. Yeah.
Yeah, and why this particular yeast would be living in the gut of a wasp is another good question. And Dr. Madden is probably better to talk about that than me, because I know she's done some investigative work on the symbiotic relationship between microorganisms and insects. Mm-hmm. And but yeah, so that's how that transpired.
That's fascinating. Well, and I'm wondering, when it comes to other sour beers, how are those made? If are there, because you mentioned that Saccharomyces doesn't produce or doesn't have this pathway towards lactic acid. Are they adding bacteria that yield lactic acid when you make sour beers? How does that work in the typical way?
Yeah, so there are various different ways of making sour beer. If you ever get a chance, maybe you've already been there, to Belgium, and the lambic beers there are made essentially, at least the traditional lambic beers, with the microbiota that are in the brewery itself. So they leave the wort, the sugar solution, open to the atmosphere at the beginning of the fermentation. And the different microbes that are in the brewing environment get into the wort, and then there's a cycle starts of the fermentation where you get different microbes will ferment different parts of the wort over a very long time period. I mean, it could be 18 months or longer.
Wow.
Yeah, these traditional sours. And so what they do, they have Saccharomyces cerevisiae there, which is the main alcohol producer. But then there's also lactobacillus, which is a good lactic acid producer. There's acetobutylicum, which produces acetic acid as well as lactic acid. Yeah. There's a yeast called Bruxellensis that also adds to the flavor of sour beer that comes into the fermentation at a particular point. So it's a very multi-culture yeast and bacteria both is a traditional way. Now here in the U.S., most breweries don't do it that way because they don't have this kind of, local environment within their brewery that they can trust they're going to
Yeah.
get the. So most of them use added lactobacillus prior to the actual ethanol fermentation. So they will do what's called a kettle souring prior to starting the fermentation. So after they've boiled the wort, they'll add lactobacillus in there and produce the lactic acid and then go into the primary fermentation for with their yeast is how they typically do, which is more controlled. You get a more consistent souring, but it doesn't nearly have the complexity of the traditional sours that are made in Belgium.
Yeah, that's fascinating. And when you add those lactobacilli on the early end before you have the ethanol production, does the ethanol then kill back the lactobacilli as it accumulates in the brewing process?
Yeah, and the lactobacilli actually are not very tolerant of acid. Like once the pH goes below 4, they're not very happy either. So there's limits on how sour you can get with just lactobacillus additive, and there's certainly, although I mean there are certain brewing strains of lactobacillus that are tolerant to the brewing environment. Most of them are not. Most of them are not very tolerant to ethanol, and they're not very tolerant to hop acids either. So hop acids actually act as a bactericide. That was probably how they first got to be used in brewing, was as a preservative. And yeah,
Yeah.
so the India Pale Ale that we all know, IPA, the American IPA, very hoppy. Well, the English IPA, which was the first IPA, the reason why they added so many hops to that was so that the beer would be preserved on its trip from England to India for their troops and their and whoever stationed in India. So that's why they put all those hops in them.
That's interesting. Well, I'm wondering, since you're an expert on beer, I'm wondering if you could tell us about other ingredients that are added besides hops. I've heard of a plant called Merica Gale that was used in Scotland. I mean, kind of before hops overtook like this role. Do you know anything about that? If not, we can cut this section. If not, it's like.
Yeah, I'm not familiar with that particular additive, but I mean, one of the things about brewing is that, especially historically, it was a very local industry. So people would use things that they could grow locally as additives to their beer. And if you look at Europe, like a lot of the hop varieties, it's very interesting. Some hop varieties will only grow in an area of a few square miles. Like there's a particular microclimate and the particular kind of soil, etc. It's just like that about how wine varieties, can this terroir. It's very specific on what kind of results, what kind of plants can grow there. So hops, hops were some varieties were grown in Central Europe, some were grown in the UK, and there were quite different kinds of varieties. And even to this day, when you order hops, the UK varieties compared to the Central European varieties are quite different. And so you can use a lot of different local herbs and spices. They probably, most of them would not have the same kind of bittering effect as hops. But, beer is very much, from my perspective anyway, a creative endeavor. So as long as people are willing to drink it, then it's a success from my point of view.
Great. since this discovery of the Lachanacea yeast strains, I know that a company's been formed. Where are things going with that discovery? Are there plans to roll this out to a larger scale utility in brewing?
So the company's been in operation now for about 3.5 years, and we've been selling the yeast mostly locally in North Carolina. I do have a customer in Florida, but I've been producing the yeast in a wet form and selling it to, say, local brewers in North Carolina for making their sour beers with it. And mostly what they do is they add some kind of fruit flavoring post fermentation. Okay, so it tends to go well with different kinds of fruit. Personally, my favorite style that we've made in our brewery, I use either lemon or lime zest.
Ooh.
Yeah, and I put that into the kettle, and that gives the beer. It's almost like a lemonade, honestly, at the end of the fermentation. Um, but each brewer tries a different kind of recipe. They come up with their unique products. The problem I have, okay, there's a few problems with spreading the technology further afield, is that the brewery really needs to be able to propagate the yeast themselves, because it's not economical to ship large quantities of wet yeast around.
Mm-hmm.
Yeah, so if a larger brewery has their own propagation facility or ability, then I can always send them a starter culture. But it's surprisingly few craft breweries actually do their own propagation. So one of the things my company has done is we've designed our own propagator, and and we build them. We will lease them to a brewery if they would like to propagate their own yeast. So if they're outside of North Carolina and they would really like to try this technology, they could lease a propagator from us, and that way they could implement their own, and they could use it for growing all their own yeast, actually. But it's interesting, a lot of brewers, though, are hesitant to take that responsibility for growing their own yeast, which I find kind of interesting, because to me it's such a fundamental part of brewing to be able to prepare your own yeast, that I would have thought, most brewers would want to do it, and you can save a lot of money too by doing it.
I bet.
Yeah.
Well, what does this mean for home craft brewers? I know during the pandemic, a lot of people rediscovered a love for baking, for brewing, for doing things on their own at home. How difficult is it to break into kind of home brewing?
Well, home brewing is not difficult. I mean, it's interesting. There's a saying that anybody can make beer, but not everybody can make good beer.
That's right. Yeah.
So home brewing is fun pastime, and you never know what you're going to get at the end of it. Depends a little bit on how much you want to invest in the equipment, because the two downfalls in my experience with home brewing that a lot of people don't appreciate enough is sanitation, for one thing.
Mm-hmm.
It's very difficult to make beer in a sanitary fashion in your kitchen, compared to if you have an actual physical setup for it somewhere else. And as a result of that, a lot of the home beer gets contaminated with something, and then it becomes very inconsistent, the quality from batch to batch, and you may be really happy with one batch and then try and do it again, turns out totally different. So so there's that aspect, and the other aspect to it, which is really important, is control of temperature in the fermentation, because the yeast metabolism is very sensitive to temperature changes. So if you just stick your fermenter in the closet or something, and your temperature in the house is going up and down, and the yeast is not going to be happy, and you'll end up with again, an inconsistent result. So you can kind of get frustrated. I think some homebrewers get frustrated when they get a really good batch they really like, and they try and do it again, and for some reason it doesn't come out the same. But it's you have to just take it as a learning experience, and it's fun, and trying to troubleshoot what may have gone wrong is a challenge. And so if you're up to those kind of challenges, and you want to persist, you can make good beer with relatively inexpensive equipment. Now, again, if you want to invest more, where you've got good temperature control over your fermenter, and you're able to to have aseptic connections between your different vessels, and that kind of thing. So if you do that, you can make beer just as good as a pro. So if you stick with it, but it's a learning experience. I mean, it's even though there's a lot of books out there telling you the science behind what's going on, it's the attention to detail that really determines the quality of your beer. So one little slip up in a transfer from one vessel to another, and you get contaminated, then your batch is gone. So you have to really be kind of a detail-oriented guy or girl.
Yeah, that's great. It really is, I think, in the spirit of science fair, which is so fun, that the Lachanacea work came out of a local science festival. That's great. Well, where can the listeners find out more about your work and about Lachanacea? Is there a website we can direct them to?
Yeah, so there's a company website. It's just www.lachanacea.com. That's LACHANCEA.com. And they can look there and contact me through the website if they're interested in learning more about it. And there's also, if they're interested in the Wolfpack Brewery, which is separate from my company. Wolfpack Brewery is in our department at the university, and we have a lot of things going on there. It's interesting. We're one of the, if not the first, university brewery to be licensed by the TTB. And that was must be close to 5 years ago now. And so we've been selling beer commercially from our Wolfpack Brewery for quite a few years now. And I use the revenue from the beer sales to help with my graduate students and their research. So it's kind of and also gives the students some fun learning how to brew beer. So
yeah, I would have loved a class like that or a lab opportunity like that in college. That's amazing, and it's helping to fund student research. That's fantastic. Well, thank you so much, John, for coming on the show. This has been a lot of fun. I learned a lot about brewing. You really did a great job in explaining the details.
Okay, well, I enjoyed it. I always love to talk about making beer, and the time just flies by. That's
great. Great. You've been listening to Foodie Pharmacology, the science podcast for the food curious. You can find this and all of our other episodes at our website at foodiepharmacology.com. We also have videos of our recent episodes that are posted on the YouTube channel known as Teach Ethnobotany at YouTube, and you go to the Foodie Pharmacology playlist. Thanks so much for listening. Stay healthy out there, and I'll see you next time.